Hello friends, welcome to my channel. Let's continue on the examples of interval merge type problems. So in this video, we're going to examine problem 495, Teemo Attacking. In this video, we're going to share a treatment based on transforming the current problem into the interval merge type and solving it using the general idea. And because this problem is an easy problem, we are also going to comment on a shortcode based on essentially the same thought. So with that said, let me briefly see what we are going to do. So first, we are going to read through the problem statement to digest the requirements, and then we do the analysis, and finally we share the codes. First, let's look at the problem statement. So our hero Teemo is attacking an enemy Ash with poison attacks. So when Teemo attacks Ash, Ash gets poisoned for an exactly duration seconds. So more formally, an attack at second T will mean Ash is poisoned during the inclusive time interval T plus duration minus 1. So this is a closed interval. So if Teemo attacks again before the poison effect ends, the timer for it is reset, and the poison effect will end duration second after the new attack. So we are given a non-decreasing integer array called time series, where time series I denotes that Teemo attacks Ash at second time series I. And also we are given an integer called duration. So we are required to return the total number of seconds that Ash is poisoned. So here are two examples. So in example 1, so the time series is 1, 4, and duration is 2. And in example 2, so the duration is the same, but the time series is 1, 2. If you compare the two examples, so in the first example, there's no overlap for the poisoned duration, and in the second example there is overlap. So you can examine based on the explanation. The output for example 1 is 4, and for example 2 is 3. So with that said, let's also look at the constraints. First, the time series list is not empty, and its length is bounded above by 10 to the power 4. So this number, 10 to the power 4, is a decent large number, which defines or given a cap on the problem size. The second constraint is on the elements in the time series list and the duration, so which are all non-negative and bounded above by a large constant, 10 to the power 7. And the third constraint or assumption is that time series is sorted in non-decreasing order. So this is actually a very useful information, because in general, if we are just given a list about a list of times, if they are not in a sorted order, we need to do some sorting. So with that said, we are ready to do the analysis. So first, let's look at the treatment. So we are going to transform the current problem into the interval merge type, and after we identify this problem as an interval merge type, such as Leetcode problem 56, 57, so we can solve it using the general sort plus linear scan method. But here, the time series is already in sorted order, so we do not need to do the sorting again. So this is the item 1. So next, we are going to look at the identification. So this is actually very straightforward. So each element T in time series actually corresponds to an closed interval. This is as specified in the problem statement. So as the time series is in sorted order already, so the corresponding intervals are also organized with non-decreasing starts. So this is the one point. Another point is that the time reset in this sentence here is nothing but corresponding to exactly the interval merge as in problem 56 and 57. So the above two observations establish the identification. So before we write the code, let me make some comments. First, this problem is special compared with problems 56, 57 in the sense that the intervals here have fixed length. So this is one point. Another point is that this problem actually can be solved easily with very short code. However, here our main purpose is to cast this problem into interval merge tab and solve it in a uniform fashion. So once we solved it using this general fashion, so we will quickly write a shortcode, and essentially the reasoning is the same. So in the next video or a follow-up video, we will examine another example, that is Leetcode problem 763, partition labels. So this problem can also be transformed to interval merge tab problem and be solved using the general sort plus linear scan idea. So with that said, we are ready to look at the code. So first, I'm going to make a corresponding interval list corresponding to this time series. So this actually can be easily done use a list comprehension. So let's see, make an interval list, right? So I'm going to call this an aux. So here I can use list comprehension. So here t plus duration minus 1. So for t in time series, right? So each t corresponds to an interval here, right? Because t is in a non-decreasing order. So these intervals also organized in a non-decreasing starts. So this is the line here. So here also I'm going to introduce this n. This is the length of this guy. It's actually also the length of time series, right? And in general, so if this list or generic list is not sorted, so for this type of problem, or as in problem 56 or 57, so we can do a sort, so aux sort. But here it's not necessary, right? Because it's already in sorted order. So with that done, so let me first treat a very special case, outside case, edge case, if n equals 1. So in this case, we just need to return the aux 0, 1 minus aux 0, 0 and plus 1, right? So this is the time. So next we're going to consider general case and do linear scan as in the general idea. So for this, if you haven't checked out the previous videos, you'd better to you are suggested to check out the previous videos so that you can follow this with ease or conveniently. So here I'm going to introduce a temp list. So this is going to hold the intervals on which ash was poisoned. So this is redundant, but we just need to print out more information. So we are going to initialize a result. So the final state of this variable is what we want to return. So as in the general case, we are going to use start and end. So that is aux 0, right? And then we are ready to do the linear scan for I in range. So we are going to start from 1 and ending at n minus 1, right? And then the current interval is given like this, right? So we are going to consider S and the moving E. So we want to consider their relation to check if there are overlaps or not. So if moving E is less than S, so in other words, S and this interval here and this interval have a gap, there's no overlap. So in this case, so we're going to append this moving E and moving S, moving S and moving E. So, and then what we're going to increment the counting, that is moving E minus moving S and plus 1. Notice that this is the time duration specified by this problem, right? So with that said, let's also do this. So we need to update the moving S and moving E, right? Moving E. So this will be nothing but S and E, right? So with that said, we checked one case. Another case is that moving E is no less than S. In other words, the two intervals have overlap, or at least touched. So in this case, so we're going to set moving S to be the smaller of moving S and S. It's actually moving S because this aux is in sorted order according to the start. So we do not need to write that. We just need to write the update for moving E, which is the maximum of moving E and E. So also one thing to notice that if I equals n minus 1, in other words, at the end of the iteration, so we need to append this moving S, moving E, and also we need to update this by moving E minus moving S plus 1. So this is the problem logic. So what we need actually is to return this result variable. So up to now, we finished a solution with some redundancy for this problem. So let's first do some check, and then the generic case. And now let's print some information. So let's print out this temp. So intervals where Ash got poisoned. So that is temp, right? So let's run this. So for this one, so this is the 1, 2. So for example 1, let's see. So we're going to the 1, 2, and 4, 5. So this contributes 2, and this contributes 2. So overall is 4. So notice that for doing this problem, we do not need this, right? We do not need this. We do not need this. Let's also comment out this. So this piece of code actually solves this problem, but this temp list gives us more information, right? Actually give us the details on when Ash got poisoned. Let's do a check. Yeah, this is one solution format. So actually, once we realize this logic, so for this specific problem, so let me write a shortcode. So in other words, we don't need to make these intervals. We can do the things on the air, right? We just need to accumulate this result. So here, let me change this function signature to be v1. Notice that this method is the main purpose for this video, because it suits the general idea. So here, for this this version of solution, let me initialize the result variable, and then first, because it's possible that this temp series it's not its length is at least 1, so we don't need to do this. So so we can do this directly. So for I in range, so 1 to length of temp series, right? So what we are going to do is that, so we compute the gap, that is temp series I minus temp series I minus 1. So we want to compare this gap with the duration, right? So if this gap is large, it means the two attack temp have no poison effect overlap. We just need to add the duration. Otherwise, we just need to add the smaller gap. So if gap is greater than or equal to duration, so this corresponds to no overlap case, actually corresponding to here, right? This if. So we're going to increment this result by duration. Otherwise, so we're going to increment by gap. and then we're going to return result. So notice that we need to add the gap because the last 10 point still have a pointing effect extension, right? That's duration. So we're going to add this duration. So this is another solution format. So essentially the same code, but if we write this directly, so it's not that lucid, I would say, maybe. So now let's do a check. Yeah, it passes one example. Now let's look at the case with overlap. So this should return 3. So now let's look at the generic case. Yeah, it passes all the generic case. With this second version of solution done, so we are done about this problem and about this video. So notice that all these problems can be cast into the interval merge type problem. So as demonstrated in version v1. So actually version v1 put this in the general idea. So actually it's good to solve different problem using the same line of idea, or solve a same problem using different methods. So here are the former. So as we mentioned in the next video, we're going to examine another problem, problem 763, right? So we're going to continue even after problem 763. So with that said, I will say thank you.